Hi, my name is Nicole Crowley, and welcome to another episode of Science is Appealing. Today's episode is on chemistry. I know what you're thinking, chemistry is boring. Well, today I'm going to introduce you to the wonderful world of chemistry.
The wonderful world of chemistry.
On today's show, I'm going to show you how chemistry applies to your everyday life through making snow anytime, anywhere, some fun tricks with balloons, and making everlasting bubbles. To make fake snow, all you need to do is add some polymer and some water. Now it continues to grow as it soaks up the water. Watch it grow as it becomes white and fluffy. And if you put it in the freezer, it hardens just like a snowball. And it feels and looks just like snow.
The wonderful world of chemistry.
Another fun experiment with chemistry is bubbles, or the interaction between soap and water molecules. Everyone knows that if you add water to soap, you get bubbles. The problem is that bubbles don't last long enough, and they break too easily. Well, there are some ways to slow down this process. First, if you are making bubbles with a solution like dishwashing detergent, you should let it sit for 1 to 2 days. Also, you should make sure the air is as humid as possible. Considering the more humid the air, the longer the bubbles will last. Wearing gloves also makes bubbles last longer, or if you could get the bubbles to land on a clean surface, considering the reason bubbles burst are mostly because they are in contact with dirt and oil. One last note about bubbles, no matter the one, the shape will always be circular.
The wonderful world of chemistry.
Okay, one last chemistry trick. If you have ever seen someone poke a hole through a balloon and it didn't pop, that's because it consists of cross-linking molecules that allow polymers to stretch. The top and the bottom of the balloon are darker than the sides because the polymers have less tension on them. So if I were to use Vaseline on my skewers and poke a hole through the top in a gentle turning fashion, it won't pop. But if I did it on the sides where there is more tension on the polymers, it would pop. To poke the sides, it would need the extra reinforcement of cellophane tape.
The wonderful world of chemistry.
Did you ever know chemistry could be so wonderful in the wonderful world of chemistry?
The wonderful world of chemistry.
Everything in the world, is made up of molecules, and some of the most useful are those that form versatile plastics, like Allothon, Delrin, Lucite, Teflon. Here's what we mean. Oh my. Molecules.
There are plastics in your toaster, in the blender and the clock, in the lamp and in the roaster, on the door and in the lock, in the washer and the dryer, and the garden tools you lend, in your music amplifier and electric fryer. You have got a plastic friend.
We can coat a waffle griddle so the waffle never sticks. Be the strings upon your fiddle, even be your fiddlesticks. Be the bristle on your toothbrush and the teeth upon your comb. In the bottle made for squeezing or a tray for freezing, with the plastic you're at home.
In your engine and your chassis,
and the body of your car. From your potter and your brassy to your shower, there we are. In your phone and in your freezer, in your television too. Cables, meters, and connections, these are just selections. Batteries and zippers, these are just a few. Cameras and skylights, these are merely highlights. In the world of plastics, all of us were made for one we wouldn't trade for. All of us were made for you.
We are learning more and more about chemistry each day. While in the 50s, chemistry was just starting off, and there's something called industrial chemistry.
From the Middle Ages down to modern times, the magic of chemistry has fascinated mankind. And to the boy of today, the subject is even more exciting. For this is the age of industrial chemistry. With vastly widened application of chemical research in manufacturing, it has attained importance undreamed of just a few years ago. All around us are the products of modern chemistry. Window shades, draperies, upholstery, and furniture. All are made of or covered with something that came out of a test tube. Radio cabinets, tabletops, and hundreds of other useful articles are made of new plastics created in the chemist's laboratory. Chemistry takes a hand in the very clothes we wear. Rayon is a luxurious fabric developed from the cellulose fibers of trees and plants. Would you believe that the leftover fuzz of cotton seeds is used to make the material which forms the backs of mirrors, combs, and brushes? Yes, the lowly cottonseed, through a chemical process, is turned into something much prettier than ivory that can be made in all the colors of the rainbow. But unlike natural ivory, this material won't crack or discolor with age. Chemistry is responsible, too, for the gossamer-like threads of these new stockings. By a miracle of modern science, such commonplace things as coal, water, and air have been transformed into threads more elastic than silk, spun from filaments even finer than those of a spider's web, yet many times as strong. Raining. Then it's chemistry to the rescue. Something that came out of a test tube is going to protect her from that shower. Here, folded into a compact little package, is a transparent raincoat, rainproof like rubber. Of a similar material are some of the new umbrellas and parasols, combining utility with beauty of design and color. Now let it rain. From other chemical processes come refrigerants that keep foods fresh, wrappings that keep things clean, insulation and wallboard to improve our buildings. Nature constantly wears away its own. Left to themselves, materials eventually decay. The pitted side of a rock, the rotting wood of a fence post, and the rusting odds and ends in the neighborhood junkyard all bear testimony to the destructive forces of air, wind, and water. Cleopatra's Needle, the famous Egyptian obelisk in Central Park, New York, is centuries old. Over all these years, nature's forces have attacked the stone. But now it has been sprayed with a finish that will preserve the famous stone pillar for centuries to come. Chemistry has also taken a hand in the preservation of wood. In this great laboratory at Madison, Wisconsin, the United States Forest Service has conducted more than 500,000 experiments, not only to find new uses for wood, but to lengthen its life. And now, fence posts telegraph poles, any wooden product used outdoors will do a better job of defying the elements. Another natural product made better by chemistry is rubber. Years of research were necessary in order to improve the product, and then testing in great machines, subjecting it to terrific punishment. Today, rubber products are tougher and stronger and have a longer life. Longer life has been given the gasoline engine too. For years, engineers were puzzled when certain engine parts like piston pins and valve stems became corroded and prematurely worn. The engineers called upon the chemists who traced the corrosion to sulfuric acid fumes formed in the engine. As a result of their studies, this ventilating system was developed to draw clean air through the engine, carrying off the harmful fumes and giving our automobiles a longer, useful life. The prevention of rust is another concern of the industrial chemist. Here, we see what happens when an ordinary nail is left outdoors for a long period. As time goes on, the iron returns to its natural form, iron oxide, just plain rust to you and me. Studies of the action of rust by means of microscopic photography and many experiments resulted in the development of rust-proofing operations for metals. Automobile bodies, for instance, are sprayed with a chemical that helps the metal to resist the elements. Bodies and fenders are treated so they'll resist the action of moisture. Then there's the surface finish of the automobile, subjected to all kinds of weather, to mud, water, and sand, to soot and smoke from city chimneys, which cover the surface with a film of gritty, scratching particles. Snow, rain, or sleet do their best to dull the gloss. And even in clear weather, there's always the gentle dew, another enemy of the finish. But chemical research has developed a finish to resist such attacks. Panels of metal covered with different types of finish are constantly tested in special machines. 30 hours in this machine under strong ultraviolet rays is equal to a solid year under the burning rays of a tropical sun. Now, the test panels are placed in the weatherometer. Here they are subjected to another ultraviolet ray treatment under intense heat. The machine revolves hour after hour, and each test panel gets a bath with every revolution, as well as intense light and heat. From the heat of the weatherometer, the test panels go into the sub-freezing temperature of a special refrigerator. Then the finish on each panel is examined. Constant experiment has shown which finishes are the best, and the result of years of patient chemical research is the surface finish used on today's most modern cars, combining with its protective qualities the radiance of sparkling colors. The automobile of today is a thing of beauty. Yes, chemistry has changed the world we live in. From wells deep in the ground, from the mine, the forest, and the farm, come the materials which are being transformed into all manner of new products. Great things have been done, but much more remains to be accomplished. Some young man, perhaps one watching this very picture, may develop a startling new formula from a test tube experiment, may give the world finer things to use, to wear, to better man's health. In this new world of industrial chemistry, the horizon is unlimited. Unexplored potentialities beckon. Hidden secrets of nature sound a call to this young man, the industrial chemist, the pioneer of tomorrow.
The wonderful world of chemistry.
Chemistry is making strides every day. It is making medicine better and cheaper. It's making alternative fuels which are more economical and cleaning up our environment.
The U.S. has a goal to produce 35 billion gallons of renewable alternative fuels by 2017. Today, CSR EES supports development of new feedstocks and conversion technologies for boosting renewable fuel production. From super yeast that improve ethanol production, to small business-developed technologies that recycle fats into biodiesel. From algae unlocking the power of photosynthesis for clean hydrogen fuel, to switchgrass, a fast-growing biomass alternative for making ethanol. Scientists are revolutionizing the way we power the country.
We're converting the energy of sunlight into biofuel. I think it is going to help not only this country but other countries around the globe to meet their basic energy needs.
At Oregon State University, land-grant scientists are studying blue-green algae, oxygen-producing strains of cyanobacteria that also produce hydrogen.
Ethanol. As America begins to shift away from gasoline, this biofuel is becoming an early popular choice. It has a number of benefits: clean burning, high octane, and it mixes easily with gasoline, like in this E85 blend that contains 85% ethanol. While most ethanol is made from corn kernels, much of what is left behind in the field is not used to produce the biofuel. The problem is that this cellulosic material, millions of tons of stalks, husks, and cobs, doesn't chemically break down like the easily fermented yellow grain. That is, until now.
I'm Nancy Ho from Purdue University. I made a super yeast, super yeast, super yeast.
Nancy Ho and her team at Purdue have been modifying a yeast called Saccharomyces. This natural yeast has been used by humans for thousands of years in the making of bread and the fermentation of wine. But now, this time-tested organism is being used to break down the corn refuse, as well as wheat straw, left behind in the field. By doing this, 40% more ethanol can be produced from the same field, a real boon to farmers. Refuse of corn has an additional natural sugar, xylose. It is xylose that prohibits fermentation, and thus the making of ethanol. Nancy Ho knew that to overcome this problem, she would need to change the genetic structure of the yeast.
There's a lot of science knowing what the yeast is missing. So I simply engineer, with the recombinant technology, you can put the genes, even, extra genes into the cells.
Genetic engineering is really a radical revolution in food production. It's really a cell invasion technology. People have heard they're taking a flounder gene and putting it in tomato so the tomato can last in cold temperatures. But people ask, how does that flounder gene get in that tomato? Let's get in there.
The number and variety of living systems is remarkable. More than 1 billion species currently exist. We now know that a principal factor in this large number is the billions of ways that 4 rather simple chemicals can vary their sequence in forming DNA genes. We are also discovering that many illnesses can be identified at the molecular level. This provides information for the design and synthesis of molecules, which can be used to treat the disease. If we examine living cells under the microscope, like these plant cells, or these bacteria, or this animal tissue, we can see the movement, growth, and cell reproduction which which are the result of successions of chemical reactions. In attempting to control these reactions, physicians have used various substances, some from nature and some synthesized in the laboratory.
The chemotherapy of cancer, treatment of cancer with drugs, dates from the early 1940s. So it's not all that old. And what has happened since about 1990 is we've turned a new page in cancer chemotherapy, and it promises a much brighter future than the immediate past. Well, cancer chemotherapy is a little bit different because each cell has an appetite and samples the compounds floating by it in the blood. And if you have agents that are capable of interfering with the cancer process, then even if it's so small, a transformed area, that you can't feel it, nonetheless, cancer chemotherapeutic agents can find it, and they will imbibe this material. Well, today is a very special day. Just over 90 years ago, 3 of my uncles knew that they had survived the First World War. Today is a special day, and I can't avoid saying something about it because it's so personal to me. But that disaster led to the first useful drugs against cancer. Long about the 1940s, a significant number of those soldiers that had been gassed in the trenches in the First World War with mustard gases began to die. And on autopsy, it was found that their bone marrow was severely damaged. The problem with that, of course, is that damaged bone marrow then decreases your immunity towards infection, and it also means that you can't make red blood cells and white blood cells and that sort of thing. Though bright people began to think about that and realized that if you used a sublethal amount of those agents, not as much as the troops had been exposed to, that might in fact be useful in leukemia where you were producing too many white cells, okay? A blood cancer. And the very first anti-cancer agents developed from that, they're called alkylating agents because they damage DNA. Well, of course, normal cells have DNA too, so you think, well, gee, that's terrible because you're just putting poisons in people. But cancer cells are dividing more rapidly. As a consequence, they have bigger appetites. And as a consequence, they selectively take up more of these things. And since they're using their DNA for reproduction, if you damage their DNA, you selectively intoxicate those. So this in fact works. For rapidly growing cancers, these kinds of agents went into effect in the 1940s and are still in use today.
On July 20th, 1976, the first Viking lander touched down on the surface of Mars.
We've got 16 kilobit data. Great, thank you.
When the Viking mission was being planned, scientists had to decide what experiments would be best to send to Mars when it's not known what kind of life might be there. Ordinary garden soil can demonstrate the reaction kinetics of living, reproducing organisms. Such soil contains numerous microorganisms. Exact duplicate of the Viking lander at the Jet Propulsion Laboratory shows what happened on Mars. The Viking collector head extended. Scooped up a sample of Martian soil and dropped the soil into the inlet. About a gram of Martian soil was dropped into the porous cup in the experimental chamber. At first, nutrient was added only to the bottom of the chamber. Thus, at first, the soil was exposed only to water vapor from the nutrient, but not to the liquid itself. This precautionary step proved to be quite interesting. After 2.5 hours, the inlet to the gas chromatograph was opened. The gases above the soil sample were examined to see if anything had happened. The signals containing the results of the first experiments went from the lander on Mars, first to the orbiter, then across the millions of miles of space to huge antennas at Goldstone, California, Australia, and Spain. The signals were relayed to Viking science teams at the Jet Propulsion Lab in Pasadena, California.
First launch back in the calibration looks proper on that. Right, about as much as we expected.
Gases were found. The calibrating gases were recorded as expected, as was atmospheric carbon dioxide. But these 3 peaks were of special interest.
Yeah, well, why don't we blow off this area? I think that everything went right with the plotting? No, data points are right on it.
The times of the smaller peaks showed they were due to nitrogen and argon, evidently minor constituents of the Martian atmosphere.
Very similar to the results we got on our test. Yeah, everything else looks the right way.
The large peak occurred at 181 seconds. Comparison to lab measurements showed it had to be oxygen. The surprise was that there was even more oxygen produced than the amount of carbon dioxide produced. Could oxygen be the product of some growth process on Mars?
Who knows where chemistry will lead us in the next 50 years? Well, that's all the time we have for today. I hope you learned some interesting things about chemistry in the wonderful world of chemistry. And I hope you enjoyed our fake snow, our everlasting bubbles, and our balloon tricks. Until next time, remember, science is appealing.
the wonderful world of chemistry.